Hi, Chris Good with another drugs mechanism, and this time we're going to be focusing on antidepressant drugs. And these include the selective serotonin reuptake inhibitors, or SSRIs, the monoamine oxidase inhibitors, or MAOIs, and the tricyclic and heterocyclic antidepressant drugs. They all work in very much the same way, and to describe that mechanism, I'm going to draw our representative synapse a little bit wider than that. Here we go. With a presynaptic neuron and a postsynaptic neuron. Now, if you haven't yet, please watch the stimulants mechanism videos first, because that will explain this model to you and why we're drawing these vesicles, dumping their transmitter molecules in. And there's actually several different neurotransmitters that we're going to be talking about, but they're all related. And they're all called monoamines. That just describes the shape of the molecule. And they include serotonin, which is often abbreviated 5-HT for 5-hydroxytryptamine. Dopamine is related to serotonin, which is DA, and norepinephrine. You might hear it called noradrenaline, but we're going to call it norepinephrine in the central nervous system and abbreviate it NE. Now, when these neurotransmitter molecules are released from vesicles, let's draw one more vesicle in here to show that we've got some serotonin, norepinephrine, or dopamine ready to go inside, right? That transmitter empties into the space between all of those neurons that contain these monoamines, and it's going to interact with its receptor postsynaptically on the postsynaptic neuron. All right? Now, whether this is an excitatory effect or an inhibitory effect depends on the type of receptor that's expressed. It depends on what kind of dopamine receptor, what kind of serotonin receptor, what kind of norepinephrine receptor is expressed postsynaptically. But we're going to talk about what antidepressants do in these monoamine synapses. Okay. When you're finished, if you're a presynaptic neuron, right, when you're finished releasing your neurotransmitter, you want that signal to stop. You want the postsynaptic neuron to understand that you're done sending that message. There's a couple of different ways you can get transmitter molecule out of the synapse. One is by using an enzyme, right, that is going to bind that transmitter molecule and break it into its component parts, right? And then you can take these parts back up inside that neuron that released it and convert it back into the monoamine neurotransmitter that you released in the first place. So these are enzymes. And this one particular enzyme is called monoamine, just like these, monoamine oxidase. It takes apart monoamines like serotonin, dopamine, and norepinephrine. So you can break transmitter molecules down. Another mechanism that we talked about before is you can use transporter molecules, just like we talked about in the stimulants mechanism, to remove neurotransmitter from the synapse and take it back up into the neuron that released it through this process called reuptake. Right? So these we could describe as monoamine transporter molecules, because they transport monoamines like serotonin, dopamine and norepinephrine back up into the neuron that released it. Okay, so the antidepressant drugs that I mentioned include one that blocks this monoamine oxidase enzyme. All right, so MOAI stands for monoamine oxidase inhibitor, and what it does is it sits here in the spot where one of these monoamines otherwise would be, and it prevents monoamine oxidase from doing its job. That means that more of the monoamine molecules are going to be left in the synapse for a longer period of time. We also talked in class about drugs like Prozac, right, which is a selective serotonin reuptake inhibitor. And when Prozac is in your body, it gets into the space between all those neurons, but it only has an effect when it finds something to stick to. And what Prozac likes to stick to is serotonin transporter, one of the monoamines. And so it inhibits reuptake selectively of serotonin. These other drugs that I mentioned, the tricyclic and heterocyclic antidepressant drugs, do very much the same thing. So these drugs, when they get into your synapse, right, they block the reuptake of serotonin transporter 2, but they also block the reuptake of transporters for norepinephrine and dopamine and serotonin, right? So they're less selective, a serotonin reuptake inhibitor. They also inhibit reuptake of these other monoamines. Now, the cool thing about all of these drugs, whether you're interfering with the enzyme that breaks down monoamines or whether you're disrupting the reuptake of monoamines, you end up improving people's mood. So if people were depressed before, they get happy. But don't let that get you into thinking that serotonin is the happy neurotransmitter, or that any of these transmitter molecules make you happy, because the blockade of reuptake or the blockade of monoamine oxidase, these things happen instantly as soon as you take the drug, but it takes a long time for your mood to change, at least a few weeks. Blockade starts within 30 minutes of you taking the pill. So what's happening in the synapse to actually make you happy? Well, one thing that we know happens in the continued presence of drugs like monoamine oxidase inhibitors or Prozac or these earlier tricyclic or heterocyclic antidepressant drugs is that the number of receptors for monoamines like serotonin actually decreases. What's happening postsynaptically is these are being taken back inside the postsynaptic neuron over a period of 2 to 4 to 6 weeks. And that's how long it takes people's mood to change when they're taking these drugs. So as we reduce the number of receptors for monoamines, we gradually see an improvement in symptoms of depression and some other disorders as well. We're not positive that that's what's happening, but there is some evidence that the delayed response of the postsynaptic neuron to the continued presence of a drug molecule is how these drugs have their effect. We'll see you next time for another drug mechanism.